Hello everyone, I'm Jong Seobom, who is in charge of presenting the group project for this computer security class. We conduct research on the subject of Einstein, a data-only attack automation tool. The table of contents is as follows. First, team introduction. Second, paper selection. Third, key contributions. Fourth, re-implementation. Fifth, schedule. First of all, here's an introduction for our team. The team name is Einstein, the subject of this study. Kim Do-won was in charge of summary of contribution. No Kyung-bin was in charge of the leader and paper selection. Park Seo-jun was in charge of scheduling, and Jong Seobom, me, is in charge of presentation. Second, here are rationales for our paper selection. Practical data only attack generation. This paper is from Usenix Security Symposium in 2024. This paper points out the limitations of existing ROP and highlights the importance of data-only attack. With advances in techniques to defend against existing ROP attacks, such as CFFI and ASLR, the importance of data-only attack emerges. Therefore, we became interested in this and selected this paper. Next is key contribution. I'll introduce practical data-only attack generation, a 2024 Usenix security paper that presents a system called Einstein. The key idea behind Einstein is quite simple. Instead of using complex symbolic execution, it automates data-only attacks using lightweight dynamic taint analysis called DTA. The authors found that data-only attacks are still realistic and scalable. When they tested popular server software like Nginx, HTTPD, and Redis, Einstein automatically discovered hundreds to thousands of potential exploits. For example, in Nginx alone, it generated 944 confirmed exploit paths. Even more interestingly, many of these attacks could bypass modern defenses, such as syscall filtering or selective data flow integrity. Technically, Einstein provides a complete pipeline. It instruments the program, taints writable memory that an attacker could control, and tracks how that data flows, and detects when tainted values reach sensitive system calls, and finally generates and verifies real exploits. Its main key is the focus on identity data flows, cases where attacker-controlled data reaches a system call argument without modification. By limiting analysis to these flows, The tool avoids heavy constraint solving and achieves practical speed. The DDA engine itself is highly optimized, using fast shadow memory and compressed text. It even supports syscall chaining, so it can automatically connect calls like open, write, and execv to simulate more realistic attacks. In evaluation, this pipeline exposed numerous exploit opportunities across several real-world servers. The two NGI and X case studies highlight the impact. In the first, Einstein found that a tainted argv array in NGI and X's leaf binary upgrade feature could reach an execv call, resulting in code execution. In another, it chained file operations to corrupt the file system through a tainted file descriptor. The broader implication is clear. Even with strong control flow protection, data-only exploitation remains possible. Defenders need to go beyond syscall filtering and focus on stronger data integrity or memory safety mechanisms. So, the point is, Einstein demonstrates that automated and scalable data-only exploitation is not only possible, it's practical. And here are our re-implementation plans. The GitHub address in the paper introduces the installation method and test method of Einstein in detail, so we would like to follow it. It says we need x86-64 architecture and Ubuntu 22.04. The test code and expected results are also shown, so verification is expected to be easy. And here is our team's schedule. We organized our team and laid a proposal presentation in October. Then we will identify some problems and devise an improvement in November. Finally, we'll implement some enhancements and write the final paper in December. Thank you for listening.